Hello, welcome to the channel. You are looking at one of the largest known impact craters on Earth. It is so big that it has its own name, the Vredefort crater. It is located in South Africa and has a diameter of about 300 kilometers. The crater is estimated to be about 2 billion years old, so it's quite old. Scientists estimate that an asteroid roughly 5 kilometers wide slammed into our planet at an incredible speed of 175,000 kilometers per hour. That's fast. It was such a violent event that it left a mark on the Earth's crust. In fact, it is so deep that if Mount Everest were placed inside it, it would disappear from view. This supervolcano had a Volcanic Explosivity Index, or VEI, of 8. For context, the VEI scale only goes up to 8. Anything above that is theoretically possible but has never been observed, so it's like saying that the real number could be higher. Now let's take a look at another supervolcano. Welcome to Yellowstone National Park. Home to bison, bears, and geysers, it is also home to the largest active supervolcano in the world. Now watch what happens when this volcano erupts. You are looking at the 1886 eruption of Krakatoa in Indonesia. It is one of the deadliest natural disasters in recorded human history, killing over 36,000 people. Its VE index was 6, the same as the 1980 eruption of Mount St. Helens. But while Mount St. Helens caused billions of dollars worth of damage and took 57 lives, Krakatoa destroyed entire villages, wiping them off the face of the earth. So why did Krakatoa cause so much more damage? The answer lies in the numbers. While both volcanoes had a VEI of 6, Krakatoa's eruption column rose 35 kilometers into the air, reaching the stratosphere. In contrast, the eruption column of Mount St. Helens only rose 25 kilometers. It did not reach the stratosphere. When a volcano reaches the stratosphere during an eruption, it gains the ability to affect the global climate. By comparison, Mount St. Helens did not have the power to do that. Krakatoa sent an estimated 22 cubic kilometers of ash and fine particles into the atmosphere, blocking out the sun and triggering climate chaos across the globe. The eruption led to heavy ashfall in Australia, India, Japan, and the Philippines, causing widespread crop failures, and Indonesia experienced devastating tsunamis and earthquakes. In fact, the 1883 eruption of Krakatoa remains the deadliest tsunami in recorded human history. The reason for this is that the energy released by the eruption was so great that it triggered a landslide in the Sunda Strait between the islands of Java and Sumatra. This landslide then generated giant waves that raced across the ocean at a speed of approximately 700 kilometers per hour. They were over 40 meters high, absolutely massive. The waves hit the nearby coastline, causing widespread destruction. But even before the tsunami, there was a first, smaller explosion which unleashed toxic gases and ash into the atmosphere. These gases included hydrogen sulfide, carbon monoxide, and sulfur dioxide. According to some sources, these toxic gases claimed around 3,000 lives in the immediate vicinity of the volcano. Then came the second and third explosions, which were much more powerful than the first. They unleashed even more ash and gases into the atmosphere. Ash fell on places as far away as the Indian subcontinent and Australia. There are reports that people in India and Sri Lanka saw red skies due to the reflection of sunlight off the ash cloud. The explosive force of Krakatoa's eruption was so great that it could be heard 4,800 kilometers away in Australia. Here is how it compares to other well-known volcanic eruptions. Krakatoa's eruption was 6 times more powerful than the 1980 eruption of Mount St. Helens in the United States. It was 300 times more powerful than the 1991 eruption of Mount Pinatubo in the Philippines and 1,000 times more powerful than the 2010 eruption of Mount Eyjafjallajökull in Iceland. The force of the eruption was equivalent to 200 megatons of TNT, which is a lot of TNT. Yellowstone's supervolcano has a much higher VEI, it's 8 compared to Krakatoa's 6. But why has it not caused more damage? The reason is that it is dormant. It hasn't erupted in about 640,000 years. If Yellowstone were to erupt today, the consequences would be catastrophic, especially for the United States. It would trigger earthquakes, tsunamis, and landslides. But unlike Krakatoa, Yellowstone's eruptions do not usually produce pyroclastic flows. Instead, they are mostly lava eruptions with very little pyroclastic material. Even so, the 1815 eruption of Mount Tambora in Indonesia, which had a VEI of 7, was so powerful that it plunged the entire world into darkness for months. The eruption cloud reached a height of 43 kilometers, injecting around 160 cubic kilometers of material into the atmosphere. The force of the explosion was equivalent to 600 megatons of TNT. Mount Tambora is now the second highest peak on the island of Sumba. It is also the youngest volcano in the Banda Sea and one of the 7 wonders of Indonesia. In April 1815, just before the catastrophic eruption, the volcano was 2,850 meters above sea level. After the eruption, it was only 1,411 meters. Mount Tambora still holds the record for the largest eruption in recorded human history. But Krakatoa, although not the largest, certainly had the most devastating consequences. Here is why. A supervolcano is defined as a volcano that has the capacity to produce an eruption of magnitude 8 on the Volcanic Explosivity Index. The Vex scale goes from 0 to 8. Anything above 8 is theoretically possible but has never been observed. Here is how each number is defined. Level 0, no eruption. Level 1, a small explosion that does not reach the surface. Level 2, an eruption that reaches the surface and creates a lava flow. Level 3, an eruption that creates a lava flow and reaches a height of 2 to 4 kilometers. Level 4, an eruption that creates a lava flow and reaches a height of 4 to 10 kilometers. Level 5, an eruption that creates a lava flow and reaches a height of 10 to 40 kilometers. Level 6, an eruption that creates a lava flow and reaches a height of more than 40 kilometers. It enters the stratosphere. Level 7, all the features of a level 6 eruption, plus large volumes of ashfall, ignimbrite and pyroclastic flows that spread over vast distances. Level 8, all the features of a level 7 eruption, plus changes to the global climate and ecosystem. Only 2 eruptions have ever been recorded with a VI of 7 or 8. Supervolcanoes are categorized into 3 types based on their shape. The first type has steep sides and is formed by highly viscous magma. These volcanoes tend to be smaller and are often found near convergent plate boundaries where 2 tectonic plates collide. The second type has gentle slopes and is formed by fluid magma. These volcanoes tend to be larger and are often found at divergent plate boundaries where 2 tectonic plates move away from each other. The third type has a combination of steep sides and gentle slopes and is formed by a mixture of highly viscous and fluid magma. These volcanoes tend to be very large and can form in various tectonic settings. The largest supervolcanoes on Earth are of the second type with gentle slopes. They are called silicic supervolcanoes. They get their name from the silica-rich magma they erupt, which is also known as rhyolitic magma. They account for more than 50% of all volcanic activity on Earth. The largest silicic supervolcano is Yellowstone. It has a magma chamber that extends more than 90 kilometers beneath the surface. The magma chamber is about the size of Los Angeles and contains enough magma to fill up the Grand Canyon. The magma is generated by the upwelling of hot rock from deep within the Earth's mantle. As the magma rises, it melts the surrounding rock, creating a larger magma chamber. Eventually, the pressure within the magma chamber exceeds the strength of the surrounding rock, and the magma is released in a spectacular eruption. Yellowstone has experienced 3 major eruptions in the past 2.1 million years. The oldest is the Huckleberry Ridge eruption, which occurred about 2 million years ago. It was one of the largest eruptions in Earth's history with an estimated VEI of 8. The middle is the Mesa Falls eruption, which occurred about 1.3 million years ago. It had a VEI of 7. The youngest is the Lava Creek eruption, which occurred about 640,000 years ago. It also had a VEI of 7. Yellowstone's next eruption will be the Lava Creek sequel, which scientists predict will occur sometime in the next 600,000 years. The likelihood of it happening tomorrow is extremely low, but in the grand scheme of things, it could happen any time. When it does, the consequences will be devastating. The explosion will likely trigger earthquakes, tsunamis, and landslides. Entire cities will be wiped off the face of the earth. We are talking about Salt Lake City, Boise, Butte, Great Falls, Billings, Rapid City, and parts of Wyoming and Montana. Millions of people will be affected. The eruption will also trigger climate chaos across the globe. The good news is that there are no active supervolcanoes in populated areas of the world. The closest active supervolcano to a densely populated area is Mount Vesuvius in Italy. It is an old volcano that hasn't erupted in about 4,000 years. However, it is located near Naples, a city of 4 million people. The chances of it erupting tomorrow are also extremely low. So you don't need to worry too much, but it's always good to be prepared for anything. What do you think? Let me know in the comments. Thank you for watching. Do consider subscribing. It's free. Thanks again and see you next time.